Okay, so now for problem number 23, they give us the function f of x is equal to 3 times the quantity x minus 1 squared plus 5, right? And so what I want to remind you guys of this, and then it says find the vertex and sketch the graph. Yeah. Explain how it's explain the transformation of the graph from the parent function and then sketch it by hand. All right.
That's 21. No. It says find the vertex and axis of the graph.
Okay, all right. My apologies. So actually, I said that wrong. This one wants to find the vertex and the axis of symmetry. Okay, ran out of room there. And so the vertex, this is written in the form a times x minus h squared plus k, where h comma k is the vertex. So the vertex then is literally 1 comma 5. That's where the vertex occurs. Now I'm going to sketch it anyways, even though the book doesn't ask it, just so you can kind of understand what the vertex is and what the axis of symmetry is.
Negative one?
No, the formula has a negative h. So h is actually 1. Does that make sense? Good question. The question was, hey, shouldn't this be negative 1 instead of positive 1? And my answer is no, because the formula is minus whatever h is. Okay? So h is separate from the minus sign. So h is, since I already have the minus sign here, h is actually 1. Does that make sense? All right, good. And that'll be a common mistake that people make. Okay, so be careful of that. It's always the opposite of what you see. So if you think to yourself, oh, it's negative 1. Well, what's the opposite of negative 1? Positive 1, if that's the way you think of it. All right? So now what does that do? Well, the original function f of x equals x squared, if I were to graph f of x equals x squared, because that's the parent function, it's quadratic, kind of looks like this. And it crosses at the origin. That's where the vertex is. By the way, the line of symmetry always goes through the vertex. What does that mean? That means that if I pick a point over here, that is the same distance from the axis of symmetry as this point here. So the parabola, if you were to cut it in half right down the axis of symmetry, you can flip it over on the other side, and and that's what the parabola is. The left-hand side looks exactly like the right-hand side. You can almost think of this axis of symmetry as like a mirror. Okay? But we got to graph this thing where the vertex is. So the vertex occurs at 1, 2, 3, 4, 5, right here. Now the 3, the A, can flip it if it's negative, or it can stretch it vertically or shrink it vertically. Since A is 3, that means whatever the y value would normally be, we will multiply it by 3. So this stretches it vertically. So this is my vertex 1, 5. Consequently, the line of symmetry goes through here. And then lastly, the 5 is also the y part, but we don't really care. But since A is positive 3, it's going to flip up. And if you were just to sketch it by hand, it should look something like that. Does that make sense? So that's this whole function right here graphed. Now what did they want us to say? That this is the vertex and that the axis of symmetry is when x equals 1. Does that make sense? Because it's the vertical line through this x coordinate of the vertex. Any questions?